All right, good morning, guys. It is Monday, the 14th. Happy Valentine's Day. For KAP, we already did the warm-up, but it's a mystery number. We just went over some reminders that Imagine Math is due this Wednesday, and we have quiz 4, which is cumulative of the 6 weeks. That is on Thursday. Remember that cumulative quiz counts as a quiz grade for everyone, and then if you failed any of the tests or quizzes, this can help bump you up to a passing grade. Okay, so please study for that. Today we're going to start off by watching 2 brain pop videos. They're cute, they're fun, they're exciting, and then we'll get into today's lesson. So let me pause, and I'll tell you when we start watching the videos. Oh, sorry, 1 second, my volume's not on. Sorry, people in the recording. Oh. Is it working? No. Ah! Sorry, recording people. Sorry, 1 second. Ah! All right, here we go. One more time. Gonna work.
Hey, Moby, what you doing? Dear Tim and Moby, I'm going to study the commutative property. Can you help me? From Michelle. Sure, the commutative property is a rule about how we can add and multiply things together. For example, 2 plates plus 3 plates equals 5 plates. Now we've got 3 plates plus 2 plates, and that also equals 5. What do you mean this is baby stuff? You're the one having a tea party. Besides, I'm trying to make a point. If 3 plus 2 equals 5, and 2 plus 3 also equals 5, then 2 plus 3 must equal 3 plus 2. Wow. The order of the numbers doesn't change the sum. That's the commutative property of addition. For any numbers a and b, a plus b equals b plus a. There's a commutative property of multiplication, too. 3 times 2 equals 6. And 2 times 3 equals 6. 3 times 2 equals 2 times 3. For any numbers a and b, a times b equals b times a. There we go, the commutative property of multiplication. Hey, I'm stuck in this chair.
Smash it.
Hey, can I have some more tea? May I please have some more tea?
Right. Manners. Get some. Alrighty, and then we're gonna watch one more.
Is it fun this time?
Thank you for your commentary. Remember, we're recording. Thank you so much. Here we go.
Apples. Ow. Dear Tim and Moby, what's the associative property all about? From Malcolm. The associative property deals with grouping numbers and works for multiplication and addition. You may not be able to mix apples and oranges, but we can add and multiply them. Let's throw some bananas in there too.
Bananas.
So we've got 6 plus 9 plus 4 equals 19 pieces of fruit. Using parentheses like this groups the apples and oranges together. It's a rule that we always do what's in the parentheses first. So 6 plus 9 equals 15 plus 4 equals 19. Right. Even if we move the parentheses and change the order of addition, our answer still comes out the same. No matter how we arrange the add-ins, their sum is always 19. This is an example of the associative property of addition. For any numbers a, b, and c, a plus b plus c equals a plus b plus c. The associative property works for multiplication too, but let's check it just to be sure. 6 times 9 equals 54, and 54 times 4 equals 216. 9 times 4 is 36, and 36 times 6 equals 216. It checks out. That's the associative property of multiplication. For any numbers a, b, and c, a times b times C equals A times B times C. And that's the associative property word. Now can I have an apple?
No.
Thanks, Chloe.
All right. So who can summarize what we just saw? What was one of them, Maria?
In addition, it doesn't matter the order of the two numbers you're adding.
Very good.
It will keep the same.
Very good. Okay, Saki, what's something else that you saw? Yes. Very good. What operations did we not see?
Addition and subtraction.
Subtraction and division. And if we try those out, do y'all think it would work?
No.
No. Okay. So that's basically what today's lesson is just talking about, is different properties that we have in math that allow us to work around different rules. Okay, so the first one, again, was the commutative property. Everyone say commutative. Commutative. Notice that it's a T, not an N. It's not a community, it's commutative. Okay, it's not really that big of a difference. I'll know what we're talking about from that side. So in the commutative property, we have an example right here. It says the blank of addition and multiplication expressions can be blank. What do y'all think? The order, very good. The order of addition and multiplication expressions can be flipped and still get the same answer. So we have an example with variables. We can do it with numbers as well. Nicholas, give me two numbers.
7 and 5.
7 plus 5, class is the same thing as?
5 plus 7.
Very good. In both cases, I would get 12. 12. Awesome. Okay, again, multiplication, same thing. If I did 5 times 7, that would be the same thing as 7 times 5. If I did that with subtraction, 7 minus 5 is 2, whereas 5 minus 7 is -2. Those numbers are different numbers, no matter what you think. Okay, if I did 7, well, let's not do divided by, let's do like 6 divided by 3 would give me 2 versus 3 divided by 6 would give me 0.5, 1/2. Again, those numbers are different, so that property does not work for multiplication and division.
So you did something again where when we're learning it, it's kind of straight. You don't really actually do it.
Well, congratulations, you're in KAP. You're supposed to be able to take what I teach you and manipulate it and work it. Okay? Next property, the associative. Everyone say associative. Associative is a blank of numbers in addition to multiplication problems, does not blank the answer. Does, so the grouping. The grouping of numbers in addition and multiplication does not change the answer. Okay? But I think Saki sort of said it. It only works if the operation is the same throughout. So do we see how in this example it's all addition and this one it's all multiplication? Do y'all see that? If I had different operations going on, if I had like addition on the outside and multiplication on the inside, and then I change the grouping, that would change the answer. But when it stays the same. So let's do another one. Give me some not so crazy numbers. Dustin, give me 3 low slice. 3, 4, and 6. If I did 3 plus, in parentheses, 4 plus 6, is that equal to, if I change the grouping to the first two numbers, 3 plus 4, in parentheses, plus 6. Let's just check that out. Grouping comes first according to Gemma, so 4 plus 6 is 10, and 10 plus 3 is 13 on one side. Okay, go to the other side, do the grouping first. 3 plus 4 is, and 7 plus 6 is, do I get the same answer? Okay. What's up?
I just noticed that the picture in the one below is someone's big.
Yeah, and we'll get to that in 1 second. Okay, using those same numbers but changing the operations, again, I would get the same thing. Okay, if y'all want to actually check it, you can solve it out, but I'm just going to keep going for the sake of going on. Okay, so just to review, commutative and the associative. It's gonna be, you can figure out your own ways to memorize, like which one is talking about which property. But little ways that I remember it, the commute. Have y'all ever heard like of a commute before? Does anyone know what a commute is? Okay, Miss Lyle's commute to work. What do you think that is? Yes. I'm sorry, Michaela. Yes. Yeah, when so every single day, Miss Lyle goes from her house to work, and then after school, I go from school to my house. And I drive on the same path, right? Okay, it's the same pathway, it's just a different order. It's the same distance, it's the same traveling path, I just go it in a different order. So the commutative is talking about the order. That's the only way that I come up with thinking of it. If you come up with your cute little ways, that's fine. Saki, do you have some way?
I was thinking that would sort of, what is that, the inverse steps? If you're going this way, then coming.
In a way, but I like to think of the word commute as just, it's a different order each time. I do know what you're talking about, but yeah. The associative, does anyone know what an associate is? Or heard that word?
Someone from work?
Yeah.
Someone from association.
Yeah, and someone from work. So Miss Lytle's associate, I could say that like Miss Ballish and Miss Vargas and Miss Rudd and Miss Ward are all my associates, and we tend to be grouped together because we all teach 6th grade math. So the associative property is talking about your grouping. So if I was talking about my group, my associates, I mean, technically anyone at Seven Lakes is my associate, but it's just a way to think about it. Okay? So come up with your own ways, use my ways, I really don't care as long as you know which one's good. Okay? Next one, identity. Michael already pointed out it, saying that I'm me and I'm you and me. Okay? Identity property is just talking about where it doesn't change its identity. The number stays the same. So in addition, what can I add to any number that stays that number? Zero. In multiplication, what can I multiply where it does not change the value? One. Very good. Okay? The identity property is where it stays itself. Good? Moving on. Inverse. Inverse is talking about like opposites. We have an additive inverse and a multiplicative inverse. Ms. Lytle has used those words before this year, and y'all probably have forgotten them already, but it's okay. Here we go. The additive inverse, adding a number to blank is equal to 0. If I had 4 plus what gives me 0? Negative 4. So adding a number and its opposite. What's the opposite of negative 67? Positive, and then if I added those, I would get 0. With multiplication, what can I multiply by to get 1? They gave you a hint. A times 1 over A is equal to 1. What is that? There's a name for it. What is it? The reciprocal. Multiplying a number by its reciprocal. Y'all remember those reciprocal words? When does the reciprocal come up? Division of fractions, okay? And some of y'all are like, Miss Lytle, I don't really think that's right. Can you prove that? Yes, of course I can. Let's take a number. Michaela, what's the number? 7, okay? Class, what's the reciprocal of 7? 1 7, okay? To multiply times 1 7. To multiply a whole number times a fraction, I need to do what first? Very good. And then top times top, bottom times bottom. 7 times 1? 1 times 7? A number over itself? Oh, she's right. Look at Miss Lytle being right. She's right. Okay? So, these properties are statements that are true for any number. Do you think if I use decimals, these rules would stay true? No. Yes. For any number. But what operations don't they work with? Subtraction and division. Very good. Nothing too crazy. So what we're going to do now is we're going to practice. Okay? These are, remember how Ms. Lytle said that when we wrote exponents, when we did exponents like 5 to the 3rd is an equivalent expression to 5 times 5 times 5. These are equivalent because they get me the same answer. Y'all remember that? Okay? properties are more examples of equivalent expressions because I can write it two different ways, get the same answer. Okay? So for these things, we are saying we want to determine whether the two expressions are equivalent, and if so, tell what property is applied. If not, explain why it doesn't work. Okay, so what I want to show you. So for number one, we want to see if 7 times 3 times 2 plus 7 times 3 times 2, we want to see if that's equivalent. If you forget everything about the properties, you can just solve it, can't you? And see if they are equal, equivalent? Yeah. Okay, so let's just do that. If you ever were confused, I'm just going to split it so I can show my work. I'm going to do my grouping first. 3 times 2 is, times 7 is 42. Over here, 7 times 3 is, times 2 is. Are those things equivalent? Yes, but hopefully I already knew that. And which property is it? What is changing with those two?
Their order.
Not necessarily the order, but the grouping, okay? And which one was talking about the grouping?
Associative.
Who's this? I'll group with my associative property. Okay, let me do one more. Let me do number 2, and then I'll let y'all do the rest of the page. Okay, already, should I be thinking equivalent or not?
No.
Why should I already be thinking that? Because of division, okay? Division, what property are they trying to do? This one, they're changing the order. So I would put in your own words, this I was going to put some childish words. Division, no working. With, this is order, so commutative. And no working, okay? So, you're gonna do the rest of them except for this last, no. Let me see. Do y'all have a number 9? No, you're good. Finish the page, ready, set, now. All right, here is the answer page. The review, sorry, number 2 was not, they were trying to use commutative on division. 23, or sorry, number 3, 27 is not equal to 1. Okay, they were trying to do the inverse, maybe. I don't know what they were trying to do, but they were failing at it. Number 4 was yes, identity. 5, again, why should it be going off that no, I can't do it on 5? Because of subtraction. 6 is yes, identity. 7, yes, commutative, because they changed the order. And number 8, again, I see division, I'm automatically like, I don't think so. Okay? Last 2 questions, number 10 and 11. Using properties right to equivalent expressions that could be used to determine the total cost. Do we agree that 6 times 48 should be the same thing as 48 times 6? Yep. Yes. You didn't have to put the property, but I just did it there to defend myself. And then 11, pretty similarly, they just changed the grouping, and it said to not change the order. Any questions? Okay.
Did I see the number 3?
Number 3, again, number 3, they said no, because if you actually solve it out, when in doubt, solve it out. 27 times 1 is 27, that is not equal to 1. All right, so what you're going to do with a partner, with like someone at your table, you're just going to go through and mark true or false. Is it equivalent or not? Okay, go through those, and then we'll check them in a second. I'm going to start a little sneak peek if you're quick at it. Pause and play when you are ready. Let me try it. All right, here is the key. True, 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 false, true, false, true, false. These, these 2 were not on your page. That's fine. True, 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 false, false, false. No, y'all should have had some blanks, right? Were those 2 there? No. Okay. Oh, y'all had different ones. Okay. The homework is this page. Thank you and good night.